Hi everybody, we're going to look today at Unit 1, Lesson 4, okay? So I want you to open your books up to Unit 1, Lesson 4. And if you have to hit pause to go get your book, do that, okay? And what we're looking at here is scaled relationships. So we've been talking about these scale figures, and we're going to find out about the relationship between scaled copies today, all right? So what it says here is each of these polygons is a scaled copy of the others. So we know that we multiply by something to go from one to the other. And we can go back and forth using a reciprocal factor, right? If we flip the fraction over, we can go back and forth between those. Let me erase those lines. The first question here says, name two pairs of corresponding angles. And what can you say about the size of those angles? So first thing I want you to do is name two pairs of corresponding angles. And you might say something like angle CDA corresponds to angle GHE, and that corresponds to angle KLI. So you could say let's say one pair of corresponding angles would be angle CDA and angle GHE. There's the first part of your question, okay? So I'm going to ignore that third one for now. Maybe we'll do a second pair of corresponding angles for the second part of this. All right? Now the next thing that it's asking is, what can you say about the sizes of those corresponding angles? I'm going to do a little bit of magic here, but what I want you to do is to do what I'm doing, only with a piece of tracing paper, maybe a napkin, some kind of thin paper that you can sort of see through, okay? I'm going to pretend this green rectangle that I just put over here is a piece of tracing paper. And I'm going to trace angle CDA. So through my tracing paper, there is the size of my angle. Now, with a little bit of computer magic here, I'm going to pretend this is tracing paper, and I'm going to slide this over and match it up with the other angle. And I notice something. When I do that, I notice that those two angles are the same. Okay, so I want you to do that with a piece of tracing paper. Trace one angle, slide it over to the other figure too. Can you see through that tracing paper? Can you see that those angles are the same size? But maybe that's just with this angle. I want you to pause and try that with another angle, with another pair of corresponding angles. Okay, so same idea, tracing paper, piece of napkin or something, trace over an angle, a different angle, and see if it matches up, see if it's the same size as the angle in one of the other figures. So I wanted to check the angle at the bottom, so I have angle HEF. And I want to check to see if that's the same as angle DAB, its corresponding angle, or angle LIJ, the corresponding angle in the smaller polygon. So let me move it over. And if I line it up, I wish we could see through these, but if I line it up just right, I can see that those angles are the same size. So part of the lesson in this book is going to say to use a protractor, but I find using tracing paper a lot easier to do, a lot easier to see that those angles are exactly the same size if I move things around. And again, it says down here at the bottom, check your prediction by measuring at least one pair of corresponding angles using a protractor. We did that with paper, so we don't really need to do this part of it, okay? Now this slide, or this page, is asking us about those same polygons and what's the relationship between their sides. So here's the problem. We mentioned this last week. Measuring diagonals, like here, is hard to do. Sometimes all we can do is measure acrosses and downs. So that's what we want to look at here with these polygons. We have in this table, it says the side lengths of the polygons are hard to tell from the grid, but there are other corresponding distances that are easier to compare. Identify the distances in the other two polygons that correspond to DB, and DB is right here, and to AC, which is right here. And we're measuring those because they're easy to count. So we're going to go look in this table. In polygon ABCD, We have length of dB, and they counted that for us, and they said that dB is 4, and I think I agree with that. dB is 1, 2, 3, 4 units long. dB is 4. And AC, from the bottom to the top, if I count those units, 1, 2, 3, 4, 5, is 6 units long. Now what this table is asking is, in polygon EFGH, that's the second polygon, can we find the distance that corresponds to dB? Well, dB went right here, so the one that would correspond to it would be this one. How long is that segment, or that, it's not really a segment, it's not there, is the length of HF? Well, I could count 1, 2, 3, 4, 5, 6. That's 6 units long, so I'm going to write HF equals 6. And then the next one down, in IJKL, that same corresponding piece, how long is that? That's LJ. And that one looks like it's 2 units long. Now what I want you to do is go back, hit pause, go back, and we've figured out from A to C is 6 units. What's the name of the corresponding segment in the second polygon, and how long is it? What's the name of the corresponding segment in the third polygon, and how long is it? So pause and count those out and fill in that table, okay? Now it says, look at the values in the table. What do you notice? What do you wonder? Pause here so your teacher can view your work. Can you write down for me, is there some kind of relationship between those values? Between these numbers and these numbers? Between these numbers and these numbers? Okay? Can you find a relationship for me? I want you to write that in your book. I'll check that at another point, okay? So on this page, it says the larger figure is a scaled copy of the smaller figure. And we notice in those pictures, we only have 2 numbers. We have this number 6, and we have this number 15. It only gave us 2 numbers. Then it says, if AE is 4, how long is the corresponding distance in the second figure? Explain or show your reasoning. Well, AE, that 4, there's nothing there, right? But that's okay. It's still the distance between those 2 points. It's telling us that's 4 and wants us to figure out how far it is from H to L. Well, we can use the reasoning that we have here. We know these are scale figures. How can we go from 6 to 15? What number would we have to multiply by to go from 6 to 15? So we think in our heads, well, let's see. 6 doesn't go into 15 evenly. But from 6 to 15, let's see, 6 times something gives me 15. It's not 1, that's too small. It's not 2, that's too small. And it's not 3, that's too big. What number could go there? And then, if you figure that out, can you do the same thing with that 4? 4 times that same thing to give you what? So that scale factor is what we're talking about, going from one figure to the other. So take a couple minutes, try to figure that out. And then it says if the distance from I to K is 5, what would the distance between B and D have to be? So take a couple minutes, give those a shot, okay? Okay, this next page is talking about scaled or not scaled. These 2 figures look kind of alike, and it says, my says that polygon these are hard to say, ZSCH is a scaled copy of polygon XJYN, but Noah disagrees. Do you agree with either of them? Explain or show your reasoning. So I want you to hit pause and write what you think in that spot. Whether you're right or wrong, doesn't matter. I want to know what your reasoning is, okay? So start to verbalize, start to put down in words what your thought process is. Okay, so once you've answered question number 1, I want you to record your answers in this table in number 2. Okay, it says record the corresponding distances in the table. So in quadrilateral HJYN, record the distance, the horizontal distance XY, And then record the horizontal distance, the vertical distance, JN, so between J and N. And then do the same thing for the other polygon, for ZSCH. Record the length of ZC, record the length of SH. Okay, so write those in the table. Hit pause, write those in the table. And then when you're done with that, it says, again, record at least 3 pairs of corresponding angles using a protractor. I don't need you to use the protractor. I would like you to use your tracing paper. So you don't need to write them down, but I do want you to indicate what you notice about those angles. Are they the same? Are they not the same between the two shapes? Okay, so take a minute, compare those angles with a piece of tracing paper, and tell me, are they the same or are they not the same? And now, based on what you just told me, do the results for those polygons, do they change your answer to whether you agree with my or whoever it was, Tyler or Diego, whoever the other person was? Does that change your answer? Okay, so hit pause, answer that question for me. And now we have a similar question. Kieran says that polygon EFGH is a scaled copy of polygon ABCD, but Lynn disagrees. Do you agree with either of them? Explain or show your reasoning. Okay, so between those two polygons, here's what I noticed. The angles are the same. Those two angles are the same. The corresponding angles are the same in each polygon, but the sides are different. Could those be scaled copies of each other? So pause here. Think about that. I want to see a good explanation. All right, so answer in good full sentences. Do you agree or not? And tell me why. And then if you're doing really well with this and you want to try this, are you ready for more question? You can. And then the last thing in this lesson is to compare these pictures of birds. So here are 2 pictures of birds. Find evidence that one picture is not a scaled copy of the other, and be prepared to explain your reasoning. So here are the 2 birds. I want you to tell me what you think. If you use tracing paper, if that helps, that's great. If you can measure some things and give me some numbers, that's great as well. So hit pause and decide for me, are those scaled copies of each other or not? Okay, we're ready to wrap up today's lesson. We're going to read through the lesson summary. Here's the important stuff, and there's a lot in this one. All distances in the copy can be found by multiplying the corresponding distances in the original figure by the same scale factor, and that's the key, is it has to be the same scale factor whether or not the endpoints are connected by a segment. For example, polygon STUVWX is a scaled copy of polygon ABCDEF. The scale factor is 3. The distance from T to X, which isn't there, the distance from T to X is 6, which is 3 times the distance from B to F. So there's no line there, but we can still measure them. We could count and see that each of those pieces is multiplied by 3 to go from the small one to the big one, or multiplied by 1/3 to go from the big one to the small one. The other important piece of information, all angles in the copy have the same measure as the corresponding angles in the original figure, as in these triangles. 42 corresponds to 42, 78 corresponds to 78, 60 corresponds to 60. We say those are scale copies of each other. We also sometimes say they're similar triangles or similar figures. These observations, it says, can help explain why one figure is not a scaled copy of the other. So, for example, even though their corresponding angles have the same measure in this picture, we have 2 rectangles, right? Their corresponding angles are the same, but the different side lengths have different scale factors. So, in other words, to go from 2 to 1, we would divide by 2. But to go from 3 to 2, that's not the same relationship. So even though they're both rectangles, they are not scale copies of those same rectangles. Okay, so that's our wrap up for lesson 4. I want you to try the practice problems in your book after these questions, okay? And that's it for today, guys, and we'll talk to you tomorrow. And guys, I will be in a Zoom room from 2 to 2:30 tomorrow, or today, on Thursday, if you want to drop in and ask any questions about the lesson, okay? I'll put a link in Schoology, and I'll be there for extra help from 2 to probably about 2:20, okay? And if I'm not there right away, just wait for me for a few minutes. All right, and we'll see you later. Bye-bye.